Hi, this is Peter Deng, your math instructor for Math 171 Algebra. I know some of you have a difficulty understand these functions in these toolkit functions, and I want to help you to understand every function in this page. So let's look at the first page, the first function. So constant function f of x equals 2. That means no matter what x's are, the y is always equals 2. That means you can say x equals 1, y equals 2. X equals 3, y equals 2. X equals negative 3, y equals 2. That means this whole line, you can see me. So this is a constant line parallel to the x-axis because y is always equals 2. That's how I understand this function f of x equals 2 because this is constant function. Now let's look at the second function. F of x equals x means y equals x. Okay, that means you can see when x equals to 0, y equals to 0, right? So this line will pass through your coordinate 0, 0. When x equals 1, y equals 1, right? Because y equals x. When x equals 2, y equals 2, right? And when x equals negative 1, y equals negative 1. So you can just put these dots on your xy coordinate and you connect them because it's a straight line. That's why this is a straight line. Look this way. Okay, that's how to understand this function y equals f of x equals x. Okay, let's understand the third function y equal to absolute value of x. When it is absolute value, that means your y is is at least greater than or equal to 0. When x equal to 0, absolute value of 0 is equal to 0. That means your line passing through the original point, 0, 0. When x equals 1, y equals 1. When x equals 2, y equals 2. So when x is greater than or equal to 0, this line is same as y equal to x. However, when x equals negative, then it's different now because even if when x is negative, y equals absolute value of negative is still positive. That means when x equals negative 1, y is still to positive 1. When x equal to negative 2, y is equal to positive 2. That's why the line is this way. So you just plug in negative 1, 1, negative 2, 2. So you plug in these points, you connect them. That's why this is a two straight line. They are symmetric to the y-axis. That's the function of y equal to absolute value of x. Okay, that's how to understand these three functions. Let's go to the fourth function, y equal to x squared. So it's a square of the x. Again, because it's squared, that means y is always greater than or equal to 0. So your graph is above x-axis, right? Because y is always greater than or equal to 0. So let's see, when x equal to 0, 0 squared still 0, right? That is why this graph will pass in 0, 0 coordinate. Okay? When x equals 1, 1 squared is equal to 1. That means it will pass 1, 1, right? When x equals 2, then y equals 2 squared. 2 squared equals 4. That means 2, 4. Okay? Now, let's look at when x equals to negative 1. Negative 1 squared equals 1. That's here. Negative 1, 1. When x equals negative 2, y equal to negative 2 squared. That's a positive 4, right? Negative 2 squared is still positive 4. That means this is a line. They are also symmetric to the y-axis. That's why this is this way. So this is one of the most important functions in algebra. So you need to understand how to draw this line, and then this is the x squared function. Okay. Now let's look at the fifth one, cubic function. F of x equals to x cubed. Well, again, you do the same thing. When x equal to 0, y equal to 0 cubed, still 0, right? When x equal to 1, 1 to the cube, still 1. 1 equals 2, 2 cube equals 8. That's why it goes much faster this way. Okay? Now let's look at the negative. When x equals negative, when x equals negative 1, negative 1 to the cube is negative 1. So this line will pass to negative 1, 1, 1. So it go down below the x-axis. When x equal to negative 2, negative 2 to the cube will be negative 8. That's why this line looks this way. Okay? Now let's look at the square root of x. So when y equal to square root of x, well, because x is inside square root, well, the x cannot be less than 0. That means this function can only make sense when x is greater than or equal to 0. Okay? When x equal to 0, y equal to 0, right? 0 square root is still 0. When x equals 1, well, square root of 1 is still 1, right? I do not want to use 2. Let's use when x equals 2, square root, oh, I'm sorry. When x equals 4, square root of 4 is, well, 4 equals 2 squared, right? 2 squared, then square root is 2. So that means we pass in 4, 2. X equals 4, y equals 2. That means that's like look like this way. Okay? So I will talk about this 6th section first. We still have only 6 minutes. Okay, let's talk about the 7th function. X equal to the cube root. Okay. When it's cube root, x can be negative. Okay, because it's cube. So again, when x equals 0, cube root of 0 is still 0, right? When x equal to 1, cube root of 1 is still 1, right? Because 1 cube is equal to 1. Now you do not want to use 2, you can use 8, because 8 is equal to 2 cube. 2 cube, then cube root is equals 2. So when x equals 8, y equals 2. Okay? That's how you get these points. So you can plug in those 3 points, you can get the first part of this line. Now when x equal to negative 1 of cube root is still negative 1, because negative 1 to the cube is equals to negative 1, right? So negative 1 cube root is still negative 1. So you pass through negative 1, negative 1. Now you want to try negative 8, because negative 8 is equal to negative 2 to the cube. Then cube root is still negative 2. So when x equals negative 8, y equals negative 2. So you draw this line. Okay? That's how you get the cube root. Now let's look at the 8 8 function, the reciprocal, y equal to 1 over x. This one is a little bit tricky. As x become bigger and, well, because it's 1 over x, that means when the denominator is 0, it doesn't make sense. That means for this function 1 over x, x cannot be 0. Okay? So that means your graph cannot hit a 0 point because it doesn't make sense. Now you can see when x becomes bigger and bigger, 1 over x becomes smaller and smaller. That's why this graph, when x becomes bigger, it becomes approaches 0. Okay? So as later on, when you start to learn derivative and the limit, then we'll find, oh, when x becomes bigger and bigger, 1 over x becomes smaller and smaller. That's why this line this way. But when x is very small, 1 over x becomes bigger. That means when x approaches 0, very, very small, and the 1 over x becomes bigger and bigger. That's why this line is this way. Okay? Now, if on the flip side, because x in the denominator can be negative, so when x approaches negative, smaller, and when x becomes very small and small, to the point of the negative infinity, then it becomes almost 0. When x from the negative approaches 0, it becomes bigger and bigger. That's why this is also a line, they are symmetric to the x coordinate 0, 0. So this is a 2 line, they are symmetric to the 0, 0 point. Okay? Now so let's look at the last function, f of x equals 1 over x squared. Okay? So 1 over x squared, because x is squared, that means your y is 1 over x squared. That means y cannot be negative, so it's always positive. And x is in the denominator, so it cannot be 0. Okay? But the difference from this 1 over x squared versus 1 over x, because it's similar, right? When x becomes smaller and smaller, it approaches 0. When x approaches infinity, I'm sorry, when x becomes bigger and bigger, 1 over x squared becomes bigger and bigger. So that's why as x becomes bigger, it approaches 0. That's why when x becomes smaller, approaches 0, it becomes bigger and bigger. So this is also a symmetric line, symmetric to the y-axis, because when x equals positive y, it would be same as x equals negative 1. So when x equals positive 1 or negative 1, the y is always 1, right? When x equals 2 or negative 2, it is 1 over 2 squared, or negative 2 squared is 1 quarter. So when x equals 2, y equals 1/4. So that's why the graph like this way. Okay, so I want to understand how these lines, why this function have these kind of lines. Then you can understand how to do your homework. Okay.